Addition and subtraction with rational expressions is the most complicated. Multiplication and division easier. Once again, let's start by looking at numeric fractions. So if I have the fraction 3/5 and I want to add to that fraction 4/15. The first thing to do is to get a common denominator. When we're talking about a fifth, we're talking about like a pizza sliced into 5 slices. However, when we're talking about a 15th, we're talking about a same pizza sliced into 15 slices. Since the slices are not of equal size, we can't really do addition. So in order to get equal size slices, I need a common denominator. I recognize that 15 has 2 factors, 3 and 5. The factor of 5 is already in the denominator of 3/5, so 3/5 is missing the factor of 3. As long as I multiply both numerator and denominator by the same amount, I don't change the value of the fraction, I just change its look. So this problem becomes 9/15 plus 4/15. Now that I'm adding the same size slice, I just need to add the numerator. There are 9 slices plus 4 more gives me a total of 13 out of 15 slices. So when I look at an algebraic problem, my first step is to factor the denominator so I can see what factors are present. So I recognize x squared minus 4 as the difference of perfect squares, and I know that that factors to be x plus 2 times x minus 2. That means that my first fraction is missing the factor of x minus 2. Just like I did with the numeric fractions, I need to multiply both the numerator and the denominator by this fraction, or this factor. So my problem becomes x parenthesis x minus 2 all over, and I truly do not have to do the multiplication in the denominator. I can leave this in factored form. So x plus 2 times x minus 2. And then I'm adding to that 2x minus 3 over the x plus 2, x minus 2. Now I have a common denominator. So all that I need to do is, let me write that common denominator, is add my numerators. But first I'm going to have to use the distributive property. So when I distribute in the first fraction, x times x is x squared, and then x times a negative 2 is going to be minus 2x, and then from my second fraction I have plus 2x minus 3. I combine like terms, and actually my middle terms here cancel, and so I have x squared minus 3, and that is over my common denominator of x plus 2 times x minus 2. And so that is my answer.